The objective for this video is to conduct a hypothesis test for a mean when the population standard deviation is known. For the 2015-2016 academic year, the mean score for all takers of the ACT was 21.0. The standard deviation was 5.4. A superintendent of a large school district claims that the students in her district score higher on the ACT than the national average. A random sample of 40 students from the district is selected. The mean ACT score for the sample was 22.3. Test her claim at a 0.05 level of significance. Step 1 is to state the hypotheses and identify the claim. The claim is that the students in the school district of this superintendent score higher on average than the national average. So this will be a one-tailed test to the right. Remember that the null hypothesis always contains the equal sign. So the claim in this case is in the alternative hypothesis. Since this is a one-tailed test to the right, the alternative hypothesis will be that the mean is greater than 21.0. Step 2 is to find the critical value. Since the population standard deviation is known, we will use the z-distribution for our critical value. Note that we will use the second line of the t-distribution for one-tailed tests. We should travel across to the column that is headed 0.05 since this is the specified significance level for this problem. The bottom row of this table contains the critical z-scores. This row and the one-tail 0.05 column meet at the critical z-value 1.645. Note that at the bottom of the page are some notes about rounding the critical z-values in this textbook. We will round this value to 1.65. So the critical value will be 1.65 for alpha equal to 0.05. Step 3 is to compute the test value. We will use the formula x bar minus mu divided by the quotient of the population standard deviation and the square root of the sample size. Substituting these values into the formula results in a z-test value of 1.52. Step 4 is to make the decision to reject or not reject the null hypothesis. It is always a good idea to visualize the orientation of the critical values and the test value by placing them on a graph of the hypothesized distribution. We have a normally shaped sampling distribution with a hypothesized population mean of 21.0. If the test value lands to the left of the critical value in a right-tailed test, we do not reject the null hypothesis. In this problem, we are to test at a 0.05 level of significance. We have determined the critical z-value so that 5% of the distribution lies in the rejection region. That would leave 95% of the sampling distribution to the left of the critical value. Therefore, it would be very unlikely that we would commit a type 1 error, which is to reject a true null hypothesis. But our calculated z-test value was 1.52. This does not lie in the rejection region, so we should not reject the null hypothesis. Step 5 is to summarize the results. Since we will not reject the null hypothesis, our conclusion is that there is not enough evidence to support the claim that the students in her district score higher on the ACT than the national average. In this video, we learned how to conduct a hypothesis test for a mean when the population standard deviation is known.